Hello everyone, let us see the last point of this chapter, that is Chebyshev inequality, that is Chebyshev theorem. Is that, let us see the statement of this theorem. Let x be the random variables having finite mean. Mu is the notation for mean, and finite variance is for our normal notation sigma square. Okay, let k be the strictly positive real number. K is the any constant. Then the following inequality holds. This is the statement for Chebyshev's inequality. Probability of the modulus value of x minus x is the random variable. X minus mu is greater than or equal to k into sigma. This probability is strictly less than or equal to 1 upon k square. It is a statement of Chebyshev's inequality, or you can refer this statement for some examples. We can refer this probability of this mod value. Mod is the nothing but mod x is suppose less than 1, then it means minus x x values minus x less than 1 less than x. That means mod x is less than 1 means mod x minus x less than 1 less than x. This number lies between minus x to plus x. This is the mod value for mod interpretation for any variable. Then by this we can say probability of mu minus, this is mu minus k sigma less than x less than mu plus k sigma. Probability of this is strictly greater than or equal to 1 minus 1 upon k square. Or you can refer this probability of mod of k x minus mu is less than or equal to k sigma, then it must be greater than or equal to 1 minus 1 upon k square. According to the example, we can use these three statements. Okay, now let us see the examples depend on these inequalities. A random variable, this is example number 1. A random variable x has mean is given mu is equal to 8, and variance sigma square is given 9. Variance means sigma square, it is not sigma, it is sigma square. And unknown probability distribution having some probability distribution. Okay, that is not given because it is not needed in the example. Then we have to find what is the question. Probability of x lies between minus 4 to 20. We have to find out this probability. And probability of mod of x minus 8 greater than or equal to 6. Okay, according to these questions, we are going to refer the which formula we can use among these three. Okay, now here we are going to use this statement because it doesn't contain mod value. Therefore, if second equation or second question contains mod value, that's why for this we are going to use this or this formula, and for this it doesn't contain mod value, that's why we are going to use the explicit form of this formula, that is this formula. Okay, write down this formula as it is here. This is the formula as it is. We are going to write down this is the Chebyshev's inequality. Okay, now comparing what we have to prove, this is the formula, this is the statement of the question. That means this is x as it is. That means comparing these two, minus 4 is equal to mu minus k sigma. Okay, and mu plus k sigma value is equal to 20. Now solve these equations, two equations for k, because already sigma is given. Okay, and mu minus k sigma is value is minus 4, mu plus k sigma value is 20. We have already mu is given and sigma square is given. Sigma square is 9. Taking square root on both sides, we get sigma is equal to plus 3 or minus 3. Here we are taking positive value for convenience. Therefore, sigma is equal to 3. Put this value in any one of the equation because mu is given 8 and sigma we are calculated that 3. Now put this value in any one of the equation, we get k value is equal to 4. Okay, now 1, this is the LHS side. Now RHS side becomes 1 minus 1 upon k square becomes 1 upon 1 minus 4 square, that is 1 minus 1 upon 16 is 15 upon 16. Now put these values in the equation, we get probability of mu minus k sigma is minus 4 less than equal to x less than this mu plus k sigma is equal to 20, that is our assumption, is greater than 1 minus this value is 15 upon 16. This is our first question complete. Okay, now for second question we are going to use this condition or this condition. Okay, according to the less than and greater than sign. Here greater than sign is there, that's why we are going to use this equation. If less than sign is there, then we are going to use this equation. Now here in this example greater than or equal to 6 is there, that's why we are going to use this greater than or equal to k sigma. Now write this Chebyshev inequality in this way, we get this is the formula. Now put all those values, mu is there, sigma is there. Okay, and put these values here, we get, now comparing this with this example. Okay, x minus mu is 8, it is already given. Okay, and greater than or equal to 6 k sigma, that's why comparing these two we get k sigma value is 6. Okay, now k is equal to that, because sigma is 3 here, that's why divided by 3 we get k value is 2. So put this value in the equation, we get probability of x minus mu, that is 8, greater than or equal to k sigma value I have assumed 6, is less than or equal to 1 upon k square. K value is 2, 2 square is 4. Okay, these are the first example depending on the Chebyshev's inequality. Now consider second example. A random variable x has mean of 12, that means mu is given 12, and variance, that is sigma square, is 9, that means sigma is 3. Okay, now if the probability distribution is unknown, probability distribution is not known, then we have to find, we have already seen such type of examples where probability of x is given, and we are going to find, we have already studied such examples where such type of examples we have studied, but for that probability distribution is needed. But using this Chebyshev inequality, we don't need probability distribution function, directly we can calculate this probability using mean and variance values. Okay, now here we have to find probability of x6 less than x less than 18. Now depend on this, we are again going to use this equation. Okay, less than greater than is there, therefore write down this equation as it is. This is Chebyshev inequality, we have to mug up this all these three formulas, this one or this one, three formulas you are going to mug. Now write all these values given in the example. Mu minus case, now compare this with this, we want to find out this, and we have this formula, that's why for that comparing these two we get less than 6 must be equal to this number, therefore mu minus k sigma is equal to 6 and mu plus k sigma is equal to 18. Now put this value of mu and sigma here in any one of the equation, we get k value is equal to 2. Same example as solving the earlier examples. Now put this value k, mu and sigma in above inequality, we get again on RHS side 1 minus k, 1 upon k square becomes 1 minus 1 upon 2 square, that's 1 upon 1 minus 4, 1 upon 4 becomes 3 by 4. Put this all values in the given formula, we get probability of mu minus k sigma is 6, less than x less than mu plus k sigma is 18, must be greater than or equal to this number is 3 by 4. This is our answer for this question. Okay, now let us see third example. Okay, a random variable x has mean 3 and variance 2, it is given, variance is already 2. Use, that means mu is 3 and variance sigma square is 2, that's why sigma becomes root 2. Okay, now use Chebyshev inequality to obtain the upper bound for this one. Okay, that means we have to find the probability of this plus probability of this. Now one by one let us see the first formula. The Chebyshev inequality for this and for this both are same. This is the formula. We have already seen 3 formulas here. Okay, this one, and this one. But in the example, it contains greater than or equal to. This mod greater than or equal to is here only. Okay, that's why we are going to use this formula here. Okay, now given these are the input, now comparing, we get x minus mu is equal to 3, already it is given, and sigma is root k, sigma is 2, root 2, and comparing this example with this formula, we get x minus mu value is 3, k sigma becomes 2. Okay, and put sigma value is root 2 here, we get k is equal to k into root 2 is equal to 2, k is equal to 2 upon root 2 is equal to root 2. Value of k is root 2. Put all these values in this above formula, we get probability of x minus 3 greater than or equal to k sigma is 2 here. Okay, and less than or equal to 1 upon q square, 1 upon k value is root 2 square is 2. This is first question. Now second question is same, just here 1 instead of 2 there is 1, that's why same formula we are going to use. Therefore putting this value, k is also same obviously, because k sigma here we have to find out k sigma now greater than or equal to 1, that's why k sigma value becomes here by this formula greater than or equal to 1. That's why comparing these two, what we get, k sigma value is 1. Now sigma is a constant, it is a variance given in the example itself. Put this value here, we get k into root 2 is equal to 1, therefore k is equal to 1 upon root 2. Now put this value of k, mu and sigma in our formula, we get probability of x minus 3 greater than or equal to k sigma is here in this example 1, and less than or equal to 1 upon k square. Now put this value of k is 1 upon root 2, its square becomes 1 upon 2. This 1 upon 2 becomes in the numerator, 2 comes in the numerator, answer is 2. Okay, now let us see next example. For a geometric distribution, probability is given p of x is equal to 1 upon 2 raised to x, where x is 1, 2, 3, 4 up to infinity. By Chebyshev's inequality, we have to prove that probability of mod x minus 2 less than or equal to 2 must be greater than 1 by 2. Now in the earlier example we have already given mu, that means mean, and sigma, and using those two values we put these values in the given formula, and comparing we calculate k and all those things. But here in this particular example, mean and variance is not given, that's why we have to calculate the mean and variance as per our earlier theory. We already studied so many examples depend on where a probability distribution function is given, and from that we have to calculate mean and variance and all these things. Therefore in this particular example, using earlier theory, we are going to first calculate mean and variance. Now given probability distribution p of x is equal to 1 upon 2 raised to x for x 1, 2, 3 up to infinity. Now we are going to put this formula in the tabular form like this. This is x value, put the x value in probability distribution, we get 1, 2, 3 up to infinity, and put x is equal to 1, we get 1 upon 2 raised to 1. Put x is equal to 2, we get 1 upon 2 raised to here. Just put x value, 2 raised to x is there, that's why put x value becomes 1, 2, 3, and we get this table. Okay, now we know expectation of x becomes the mean of x. Mean means mu, that is, this is the mean, is equal to mu value is equal to expectation of x, both are same. In some example we have used x bar also. Okay, but in this particular example we are going to use mu, because in the formula mu is given. That's why we have to calculate expectation of x means summation x px. This is the formula for mean. Put this value, summation means x into px, this x value into px, and addition of all this, 1 into 1 by 2 plus 2 into 1 by 2 square plus 3 into 1 by 2 cube plus 4 into 1 by 2 raised to 4 plus and infinity. Okay, now multiply this, we get 1 by 2 plus 2 into 2, 2 upon 2 square plus 3 upon 3 cube, 2 cube plus 4 upon 2 raised to 4. Now we have to solve this by using our earlier formula. Take half common from this all series. We get half common. First term becomes 1 plus second term becomes 2 by 2 plus third term becomes 3 by 2 square plus fourth term becomes 4 by 2 cube and so on. Okay, now this is like what is the common term here? 1 by 2 is the common term. Put x is equal to half in the above example. What we get? Half as it is 1 plus 2 into half value is x plus 3 into 1 by 2 square means x square plus 4 into 1 by 2 cube means x cube plus and so on. And this is the formula we know, 1 minus x raised to minus 2. This is a standard formula. What is x value? Is half. Therefore, put this x value here in this formula. We get a 1 minus half raised to minus 2. 1 minus half is half raised to minus 2 becomes 1 upon 4. It comes in the numerator. It becomes 4 and 2 to the 4, answer is 2. Okay. In this book, it is solved by some complicated terms. That's why it is not needed here. It is our regular formula. We are going to use that only. Okay. That means mean becomes 2, mu becomes 2 here. Now let us see. Here mu is 2. We have to going to calculate variance also. Okay, now expectation of x square we need for variance, because variance formula we know. Variance is sigma square is expectation of x square minus expectation of x, its bracket square, where expectation of x means mean we have already calculated, that is 2. Now we have to calculate this term. Okay, expectation of x square. Expectation of x square means just replace here x by x square in the formula. Okay, we get x square into px. That means 1 square into 1 by 2 plus 2 square into 1 by 2 square plus 3 square into 1 by 2 cube plus and so on. Okay, now here one was some adjustments we have to do. See, take half common. We get 1 plus 4 by 2 plus 9 by 2 square plus 16 by 2 cube and so on. Okay, this is just way taking half common. Now we can't use this formula here because numerator are different. Okay, now what we have to do to solve this example, just let this bracket is yes, let s is equal to this bracket only. Okay, now let a is equal to half, let x, here we use x. Now here just replace half by a. It becomes then s is equal to 1 plus 4a plus 9a square plus 16a cube plus next term will be 25a raised to 4 and so on. Okay, now multiply this yes by minus 3a. Okay, it becomes minus 3a minus 12a square minus 27a cube minus 48a raised to 4 minus and so on. Now multiply this term by plus 3a square. We get plus 3a square plus 12a cube plus 27a raised to 4 plus 48a raised to 5 and so on. Now again multiply this term by minus a cube. These are just adjustments, arithmetic adjustment. There is no rule for this, but this is the only example where this type of adjustment is given. Now minus a cube, multiply this with this, we get minus a cube minus 4a raised to 4 and plus and so on. Now if you see, if we add all these things, adding number, equation 3, equation 4, equation 5 and equation 6, what we get? S minus 3a s plus 3a square s minus a cube s. Okay, on RHS side, if you see, 9a square minus 12a square plus 3a square becomes cancel. Minus 12 plus 3 is minus 9. Minus 9 plus 9 a square becomes cancel. Here 16, 27, 12 and 1 minus 1 cancel. Okay, again 25, 48, 27 and minus 4 again gets cancelled. Rest of the all terms gets cancelled by adding all these equations. What remains is 1 plus 4a minus 3a only remains. Okay, and again 1 minus 1 plus 4a on LHS side it becomes 1 on LHS side it becomes this yes minus 3a yes plus 3a square yes minus a cube yes is equal to 1 plus 4a minus 3a. Okay, and again take s common from this, we get 1 minus 3a plus 3a square minus a cube into s becomes plus 4a minus 3a becomes plus a. Okay, this we get from this addition. Now this we know it is the perfect cube of 1 minus a bracket cube, that is a cube, because we know a minus b bracket cube is a cube minus 3a square b plus 3ab square plus minus b cube. This is a standard expansion for a minus b bracket cube, where a is 1, b is capital A. Therefore, this is the perfect cube into s is equal to 1 plus a. Now s is equal to, we want yes, this we want. Therefore, s is equal to 1 plus a divided by this term 1 minus a cube is equal to, again a resubstitute here, half. Okay, 1 plus half is 3 by 2. 1 minus half its cube is 1 by 8. Answer is 12. Okay, 3 by 2 upon 1 by 8 is 12. Therefore, put this yes here in this equation number 2. We get expected value of x square becomes half into this yes is, answer is 6. Now put this value in the variance formula. Variance is this. Put this value, we get 6 minus expected of x is 2 square. 6 minus 4 is 2. Therefore, sigma square is 2. Therefore, they take square root on both sides. We get sigma is equal to root 2. Therefore, by using Chebyshev's inequality, we get probability of x minus mu. Mu is this one. Put this value in this equation, because see, we have to find out this, and we have this formula according to our requirement. Less than equal to is in this equation. Therefore, we use this formula here. Therefore, put this value here. We get k sigma value is 2. We know k is sigma is root 2. Therefore, k value is root 2. Okay. Now put all these values in above equation. We get probability of x minus mu is 2, less than equal to k sigma is 2, greater than equal to 1 minus 1 upon k square, that is 1 minus 1 upon k square is root 2 square is 2. 1 minus half is half. Okay, this is the required answer. Okay, this is end of our chapter. Okay, next chapter we are going to see theoretical probability distribution. This is also very small chapter. Okay, in the next lecture we are start with binomial distribution. Okay, these are some objective type questions. Okay, answers are also given. Some problems are there, some theories are there. Here all problems are there, and this some theory is there. Okay, already we have seen all these formulas. It can be asked in objective type of questions. Okay, this is also theoretical questions. No problems are there. Therefore, just remember all these theories with all. These are some formulas. We have just seen all the formulas. Okay, in the assignment, write down all these objectives also in your assignment number, next assignment. Okay, thank you.